Okay, what you have on the board is chemistry. This is NECO 2023, and this is theory question. This is theory, not OBJ, not objective. Now, the question is given. Look at it here. You have it. So this is NECO, and this is question. This is paper 2, and you have question 1. Question 1, A1B, BII. That's where I am. I will solve everything. Okay, the question says, consider the reaction sodium react with oxygen to give you sodium oxide, that is Na2O. Then you balance the equation. Although the equation is balanced already from the question. So sodium is 4, 2 times 2 is 4, sodium is 4, oxygen is 2, oxygen is what? 2. The equation is balanced. Solid state, gaseous, and solid state. The question now says, from this equation, what is the mass of oxygen needed to burn 9.2 grams of sodium? The question is, what is the mass of oxygen needed? So now, let's begin. Okay, we write mass of oxygen is unknown, because they say what mass of oxygen is needed is unknown. Is needed, what mass of oxygen is needed to burn 9.2 grams of sodium. So you now write mass of sodium is equal to what? 9.2 grams, because they said what? 9.2 grams of what? Of sodium. What is the mass of oxygen? Mass of oxygen needed to burn 9.2 grams. So that is it now. What you do, you say that mole is equal to what? Mass over what? Over molar mass. So what mole are we looking for? We are looking for the mole of what? Of sodium. Then mass over molar mass. What mass are we talking about here? Mass of sodium. We now have 9.2 over what? What is the molar mass of sodium? Sodium, look at it. Molar mass of sodium is 23. Molar mass of sodium is 23. Molar mass of sodium is 23. So we have 23. So let's quickly divide that. We have 9.2 divided by 23. It gives us 0.14, which is equal to 0.4 mole of sodium. We've got the mole of sodium. That is your first approach. Now, having done that, now this is where the work begins. You now write from the equation Na2OX. So now, from the equation, this is what we will say now. From the equation below, which is this equation, 4 mole of sodium was reacted with 1 mole. There is invisible one here. Yes, there's invisible. There's one here. Invisible one. Since even if we write it as 1, it is 1 times 100 is still the same thing as what? As that same number, which is 1 times 100 is still 100. So 1 times, so it does not really count. So we have invisible 1 here. Now, we now write from the equation below, 4 moles of sodium was reacted with what? With 1 mole of what? Of oxygen. That is oxygen gas. Okay, now what do we do next? We now say that it gives me that. So 4 mole of oxygen is what I just said. 4 mole of sodium was reacted with 1 mole of what? Of oxygen, and it gives me this one. Give me this one, because we don't have any concern. We don't have any business with this one. We don't have any business with this one. So our major concern is between this and this. Our concern is between this and this. Sodium and oxygen. So 4 mole give me 1 mole. Then I already calculate the mole of sodium from the question. I got 0.4. Then I will now say that 0.4 mole of sodium will give me what? X. What do? You make S a sort of formula. Then you now have 4S. You cross multiply. 4S is equal to what? 0.4 times 1. 0.4 times 1 is same thing as 0.4. Divide both sides by what? By 4. Then you now have that S is equal to what? S is equals to what? 0.4 divided by 4, S is equals to what? 0.1 mole of what? Of oxygen. But the question said that what is the mass of oxygen? Then you can say that mole is equal to what? Mass over molar mass. Then you can say that mass is equal to what? Mole times what? Molar mass. Then mass is equal to what? Mole is 0.1. 0.1 times what? Oxygen is actually oxygen gas we are given. Look at it, O2. There is going to be 16 times 2, which is equal to what? 32. Then molar mass for oxygen is what? Is 32. Then times 32. 0.1 times 32. The answer is 3.2 grams of oxygen. So that is my final answer. Please endeavor to subscribe to my channel, and I will bring more of this content